Hello everyone and welcome to today's session. My name is Yelena and I'm from Belkasoft. During this webinar, we will discuss key challenges of Android acquisition, standard and advanced Android acquisition methods which could be used to extract the data, and what valuable data can be extracted from WhatsApp and Telegram. A few words about the Belkasoft product portfolio. There are 4 products which are Belkasoft Evidence Center X, Belkasoft Remote Acquisition, Belkasoft Triage, and Belkasoft Incident Investigations. Belkasoft X is our main product or even platform, which evolved from our older Belkasoft Evidence Center. The product allows you to investigate both mobile and computer devices. In particular, the product supports hundreds of forensically important system artifacts for Windows, macOS, iOS, and Android. Belkasoft X includes hundreds of man-years of development, tons of talks with customers, thousands of implemented feature requests from our users, modern interface with simplified yet flexible and powerful workflow, and numerous usability studies we conducted during the last years. The other product in our product portfolio is Belkasoft Triage or Belkasoft T. This is a digital forensic and incident response tool developed specifically for a quick triage of a live Windows computer. The key features of Belkasoft T are those. The product can be launched right from a dongle. With Belkasoft T, you will be able to detect more than 1500 computer, mobile, and cloud artifact types. Belkasoft T allows automated acquisition of a computer RAM dump and a partial or full export of discovered profiles. There are even more cool features in this product. One more product which is a part of our product portfolio is Belkasoft Remote Acquisition. It is a tool developed specifically for remote extraction of hard and removable drives, volatile memory, connected mobile devices based on Android and iOS operating system, and selected types of artifacts. Belkasoft Incident Investigations is a tool for digital incident investigations developed specifically for businesses and aimed to investigate hacking attempts of Windows-based computers. In this product, you can find such features as suspicious traces detection in most typical locations, including registries, event logs, and less-known files, analysis of how malicious code persisted in the system by analyzing services, scheduled tasks, WMI subscriptions, how and when malware was executed by examining various artifacts such as Mcache and Shimcache, Syscache, and others. Extraction of remote connections details including IP and timestamps for RDP and TeamViewer. There are also a capability to find potential initial attack vector by analyzing recently opened documents and browser links and latest downloads, and search inside extracted information, bookmark important data, and create reports in multiple formats. In the next section, we will discuss Android acquisition methods, which are generally known in the industry. First, let's start with the challenges that you as an investigator can come across when dealing with Android devices. The complexity and the diversity of Android applications and devices are based on their architecture models and their factory proprietary technology and formats. There are different procedures and techniques used to obtain and verify data. The Android platform is developing rapidly. Therefore, it is difficult to adapt to the new devices and to choose a method that will be suitable for the investigations and produce the most data. The hardware of the Android interface is difficult to set up and work upon. It is difficult to acquire the data from the Android devices which are running custom ROMs. Pixel experience Lineage OS, Evolution X, Corvus OS, etc. So the variety of hardware can be a real pain for an examiner to be specific chipsets. And the popular chipsets used in mobile devices under Android operating system include Qualcomm, Exynos, MediaTek, and chipsets like Kirin and Spreadtrum. Along with chipsets utilized in Android devices, one more issue with which an expert has to deal with is Android security features. The initial version of Android didn't have a full disk encryption mechanism to store data in an encrypted format within the device. As a result, extracting data from the device was much easier for a forensic investigator than it is currently. With each Android version update, more and more security features such as app permissions, trusted execution environment, and secure kernel have been added to improve the security of the platform. At the same time, these functionalities of Android platform make the process of data extraction complicated and risky. Android file system encryption can also become an obstacle during an investigation. For example, starting from Android 3.0, full file system encryption was provided, so all user data could be encrypted in the kernel. Starting from Android 5.0, full disk encryption was supported. Full disk encryption uses a single key, protected with the user's device password, to protect the whole of a device's user data partition. Upon boot, users must provide their credentials before any part of the disk is accessible. And starting from Android 7.0, file-based encryption is supported. File-based encryption allows different files to be encrypted with different keys that can be unlocked independently. As for our flagship product, Belkasoft X, there are multiple methods available to acquire Android devices. Let's discuss standard methods first. A standard ADB backup is built in the Android operating system and available on any Android device. Belkasoft X supports this kind of acquisition for a vast majority of Android-based devices. With Belkasoft X, you can acquire both physical and logical images of an Android device, where administrative rights are obtained. Logical image, which is a full file system copy, is useful when your device has built-in encryption and physical image has no sense. Agent-based acquisition uses a special application or agent installed by Belkasoft X to a device. The agent helps transfer data from the device to Belkasoft X. The range of data depends on a chipset vendor. Upon the acquisition, the agent will be automatically uninstalled by Belkasoft X. Data copying via application downgrade allows a user to install an older version of an application to a device, which allows for the extraction of data from applications that have removed the possibility of backing up their data into the standard ADB backup. Upon the acquisition completion, the original versions of applications will be restored, even if the acquisition completed incorrectly. Belkasoft X supports downgrading of multiple applications, including discussed in this webinar, Telegram, WhatsApp, Viber, and others. With the help of data copying via automated screen capture, Belkasoft X has the ability to capture screenshots of various popular applications installed on a device. You can take screenshots of chats, threads, and call lists. Handy options allow you to set a maximum number of pages to capture, which helps when working with large volumes of chat or call data. You can also specify directions for the scrolling, whether up or down. Advanced ADB acquisition method is a combination of all available methods powered by ADB into a single task. It first starts with an agent-based acquisition, then runs an APK downgrade followed by full ADB backup creation, then data from shared folder is copied. And the last acquisition method here is media files copy via MTP-PTP protocols. This acquisition method uses media transfer protocol and picture transfer protocol and allows copying pictures, audio, and video files from a device to a computer. And now let's continue with advanced acquisition methods. Belkasoft X has specific support for acquisition from devices powered by MediaTek. A number of acquisition methods are supported. Each of them has its own requirements and range of acquired data. Logical file system image, physical DOM, particular types of applications. The wide variety of MTK-based devices and MTK chipsets is supported, including popular smartphones such as LG, HTC, Sony, Xperia. Belkasoft X allows you to acquire a physical image from a vast amount of different mobile device models running on the Qualcomm Snapdragon chipset, and this method is based on an emergency download mode. The list of supported devices includes more than 250 smartphone models. And Belkasoft X also allows you to acquire a physical image of a vast amount of different mobile device models running on a Spreadtrum chipset. Previously, we reviewed a list of acquisition methods available in Belkasoft X, and now let's discuss what we can extract from WhatsApp and Telegram on Android for further digital forensic analysis. As of 2019, WhatsApp is most popular global mobile messenger app worldwide and one of the messaging apps in the Facebook ecosystem. WhatsApp tallies 500 million daily active users and 2 billion monthly users in 180 countries. WhatsApp is mostly popular, especially in emerging markets, with the largest number of users such as India and Brazil. Other countries where the app is widely used are the US, Russia, Indonesia. WhatsApp is running all Android versions starting from 4.0.3, iOS starting from iOS 9, and Linux-based KaiOS. Like any other chat app, WhatsApp was created to allow users sending and receiving text messages. There are group chats as well, which are designed to share messages, videos, images, and documents with up to 256 people at once. With WhatsApp, users can have either voice or video calls, as well as send voice messages. What's more, users can launch WhatsApp on their PCs and laptops, in web browsers, and as a desktop client. There are also such useful security features like backup data in cloud service, two-step verification, and end-to-end encryption. WhatsApp is evolving all the time, and the upcoming features which can be of importance for digital investigators include multiple device support, when a user will be able to launch an app on several devices simultaneously, WhatsApp QR code, with which users will add contacts by scanning QR code, self-destructing messages, the functionality similar to what Telegram and Signal apps offer. On smartphones running Android, WhatsApp stores its chat database in a sandbox. New Android devices are configured to exclude that chat database from ADB backups, and it means root access is required to access the chat database. There are 3 potential cases which can help you to get access to the WhatsApp data. First, downgrade WhatsApp to get an unencrypted backup file. Second, decrypt an available backup. And the third case is access the original database. Let's go through every potential case separately. There is a method to access the WhatsApp database on an old, non-rooted smartphone. The encryption feature in WhatsApp appeared relatively not long ago, so you will need to download the previous WhatsApp versions and try to bring back the unencrypted database to the host. You will be able then to extract WhatsApp data from the created file. There are two disadvantages of this method. It will not work on new Android devices, and it's quite complicated and may lead to the loss of user data. Some Android devices may contain so-called standalone backups, which were created for WhatsApp. Those backups are usually encrypted. Encrypted WhatsApp backups usually appear as .cryptxx, where XX stands for number 1, 2, 12, etc. To access the backup, you have to decrypt it using an encryption key. This key is stored in the WhatsApp sandbox, which can only be accessed with super user privileges and only in case the device has been rooted. If you have super user privileges, then you can get the required artifacts right from the original WhatsApp database in the application sandbox, so you don't need to get data from a backup. Let's find out where WhatsApp keeps its data on Android devices. WhatsApp application files on Android devices are stored in user data directories. Regular user data is stored there. You can also find some subdirectories and program files in the folders along this path, which you can see on the screen. Data.com.whatsapp. There are two important databases. First is wa.db. From this database, you get to access the full list of the WhatsApp users' contacts, phone numbers, display names, timestamps, and similar details. The other database is msgstore.db. From the msgstore.db, you get information on conversations or sent messages, such as contact numbers, the contents of the messages, status, timestamps, information on attached files, and similar data. One more thing to mention is that WhatsApp can store artifacts on an SD card. It happens when space on a smartphone's memory is limited. In this case, you will find a WhatsApp folder on the SD card's root directory, and in that folder you will see the Share, Trash, and Database subfolders. Share stores copies of files sent to other WhatsApp users, Trash keeps deleted files, and Databases stores encrypted backup copies. Let's move on to Telegram on Android. Telegram is a messenger app that enables its users to exchange messages using various communication schemes. They are one-to-one, one-to-many, and many-to-many communications. It is also designed to carry out voice calls using various privacy-preserving techniques. Telegram supports the exchange of both plain text messages as well as messages including contact information, geo-coordinates, and files of any type. Compared to WhatsApp, Telegram is a cloud-based messenger. It means that all user data, excluding secret chats, are stored and encrypted on Telegram's decentralized cloud infrastructure. As the data is stored in the cloud, it might be a challenge to extract data from mobile devices, excluding the data stored in the application cache or when the mobile device is jailbroken or can be otherwise rooted. Telegram is a feature-rich chat app. However, not all these functionalities are of investigative interest. The Telegram user account. So each user is uniquely identified by means of its Telegram ID or TID, an integer value chosen by Telegram which is associated with a phone number. Each user may optionally set a Telegram username and a profile photo. All this information may have a significant investigative value. The TID uniquely identifies the user in a chat app. The phone number may be used to tie the virtual identity of the user to its real one, and the profile photo may provide additional hints about the identity or the location of the user. The next feature of interest is contacts. Each Telegram user is associated with a list of contacts. For each contact, Telegram stores their TID, phone number, and profile photo. Obtaining this data allows an investigator to determine whom the user was in contact with, and to possibly determine the real identity of each contact by using their TID, phone number, and profile photo. So, message exchanges. Telegram provides its users with the possibility of carrying various types of communication by using chats, channels, and groups. Telegram organizes the messages into dialogues. The ability of reconstructing the chronology and contents of exchanged messages is of obvious investigative importance. As a result, it allows an investigator to determine with whom the user communicated and when these communications occurred. The identification of the properties of each dialogue in which the user was involved may provide valuable evidence in various investigative scenarios. And so, voice calls. Telegram provides its users with voice calls, which relies on user-to-user communication channels and end-to-end encryption. The ability to reconstruct the data related to voice calls is of evident investigative value. Potentially, the data which can be extracted might include when a call has been performed, to whom a user talked, and the call duration. Telegram stores various data in the internal memory of the device, and in particular in the folders of the user partition. These folders are located in the data directory in folders data, which is inaccessible to standard users and media whose access is instead unrestricted. There are four main artifacts that provide forensically relevant data. Cache4.db is the main database, an SQLite database. It is located in the database folder and contains the list of contacts of the user, the chronology of exchanged messages, the contents of text messages, the location on the device memory where the contents of non-textual messages are stored, and the log of the voice calls. Userconfig.xml is the user configuration file located in the Preferences folder, in which the details of the Telegram account used on the device are stored. The profile photos of the user and of their contacts stored in the cache folder that may reveal information about the real identity of user contacts, and the copies of the files sent or received by the user via Telegram, which are stored in the media folder. And now let's move on to the demo session, during which my colleague Jared will show you how to extract and analyze Telegram and WhatsApp artifacts.
For this demonstration, we'll be covering how to process and analyze Telegram and WhatsApp chat applications within Belkasoft X. So here we are in Belkasoft X. We select Add Data Source, Acquire, Mobile, and then we would select Android or whatever device that is we're trying to acquire. So the point of this is just show you how you would go about acquiring devices in order to get WhatsApp or Telegram. For here, if we select Cloud, we can go to WhatsApp and enter the email and password for that WhatsApp account, or we can utilize the WhatsApp QR code. Select where you'd like your target path to be, and then you would acquire. For now, what we're going to do is we're going to add an existing mobile image of an Android device. We'll select our Android device, select Next, and the only thing that we're going to actually process for is chats. And we can filter for Telegram. We can choose Telegram and Telegram X for Android operating system. And then we can filter for WhatsApp. Again, we'll select WhatsApp for Android and select Next. The rest of the settings will be default, and we'll select Complete. Over here on the right hand side, you can see the two application types that were processed for, and then you can see input required. So selecting this button will take us to the Task tab. Dropping down, you can see orange triangles with a warning symbol that says Enter Missing Data. Selecting this, you can tell that we need a key file path or a phone number to get more data. So what we're going to do is jump to the File System Viewer. We'll expand the system image that we have. We'll filter for anything that says key. Again, we're trying to find the key files. And down here at the bottom, you can see that we have some keys. So what we're going to do is check all of these that say key. We're going to export these by right-clicking and copying the files to folder. We'll select a path, and then we'll choose to open the file when it's done exporting. Now you can see that we have our keys exported to a specific path, so we'll go back into our Task tab to enter in the path to where we just stored these keys. We select Enter Missing Data and browse to that path that we were just at, select the key, select OK. So we're going to put the same key file in for all of these databases so we can decrypt them. The quickest way to do this after browsing to that key is to simply copy, and then we will paste it into the rest of it. And we'll do this for each one. Upon completion, we'll go back to the Artifacts tab. We'll expand our chats. You can see that we have WhatsApp and Telegram. We're going to start by focusing on WhatsApp. So if we right-click one of these WhatsApp chats, we can choose Show Contacts, and this is going to break out each individual person that the owner of this database has had a conversation with and how many conversations they've had. So selecting the highest number of hits as far as conversations for this particular database, we can see that this person communicated the most. Down here at the bottom, we have different viewers available, such as a hex viewer or SQLite viewer. And over here on the right-hand side, you can see the general properties. Things such as who sent the message, when it was sent, the participants of the messages, as well as where is this stored, the profile path, the origin path, the length, file type, and profile type. If we want to expand our hex into a full screen, we can select this little tab here. We can search and bookmark portions of the hex magnifying glass, and searching for specific text or hex. Jumping back into the artifacts, we can look at the SQLite again, either in the bottom or expand it to full screen to browse the data and the structure. Right-clicking on a timestamp, you can actually change the way the time is viewed. You'll notice that we were able to pull some latitude and longitude out of the SQLite database, and we can copy that, but we'll notice that there's also copied from here these little icons that show that this is geolocation. So placing a checkbox next to these items and choosing show checked items on map will display the artifacts on the map with information on each artifact. Selecting Show an Artifacts will bring us back to the Structure tab we were just at and give us more information about that particular artifact. We can also right-click and create reports straight from the map. So the reports will include the latitude, longitude, and any sort of screenshot of the map where the artifact is shown. Going back into the Artifacts tab, the next thing we're going to do is place check marks in these, and we will create a bookmark. So right-clicking, create new bookmark, selecting a category, and you can change the name of the category as well. Change the name of the bookmark, and select OK. So now we can go to that particular bookmark and see all the other artifacts that we've tagged with a bookmark. So we'll scroll through and see that we have some voice messages, how long it is, and next we can choose our available columns. So if we have too many columns or not enough columns, right-clicking on any column in this view, you can change the layout of those columns. So if we want to put the, say, duration of phone calls or voicemails next to the artifact type, we can do that in that way. So we will check these and bookmark them. Go back to our Bookmarks tab, and from here, if we select the very top, we can check all of them, and then we can right-click and create a report for the checked profiles. You can see a pretty extensive list of the target formats. If we choose Advanced Options, we can add things such as sorting, the orientation, whether or not we would need our company's logo in there. We can choose to split up or group our artifacts into files, and whether or not we want to include files such as pictures or attachments. Moving into columns, you can see for our bookmarks what we have selected. We can choose the specific columns for those artifacts, and then we can choose whether or not we want subfolders or everything under one single folder. We choose to generate the report, and displays a very detailed report. Let's go back into Artifacts, and we will switch to the Bubble Chat view. Now, if you want to create a report for Bubble Chat, you'll switch it to Bubble Chat view by selecting the little top icon, right-clicking, and creating a report for items. So here we'll select PDF, and then you can see that we actually have our report directly from our Bubble Chat view. So now we're going to switch our attention over to Telegram. We're going to cover a lot of the things that we covered in the WhatsApp, so I'm not going to go too far into it. But selecting one of these Telegram chat applications and choosing Show on File System, it'll bring us to the overarching container that is holding the databases for the Telegram application. We can look through the SQLite databases, and we can also see, based on expanding the SQLite database, that there is the support for write-ahead logs, journal files, and even free lists. Jumping back into the Artifacts tab, we can browse down to the General Properties tab and look at where the specific database is being stored and even what table is storing those messages. So we can go back to that database, go to the corresponding table, and view more information about that particular artifact. Jumping back into Artifacts, again, we can look at our built-in hex viewers and SQLite viewers down the bottom, or expand them utilizing the little pop-out button right next to them. Again, selecting a single message will highlight that artifact down below. And we can also again switch from bubble view to grid view. And right-clicking an artifact will give us all the available options for that particular artifact, whether we wanted to show it on the map, copy the text of the item, create a report, create a bookmark, and so on.
Thank you, Jared. And so this is it for today. If you are interested in testing any of the Balkasoft products by yourself, don't hesitate to request it on our website. Please also note that the Balkasoft X free trial doesn't contain Checkmate. We also have a special up to 95% discounts for educational organizations. In case of any questions, you may contact us by email shown on the screen. And our pricing is much more affordable than that of competition. We also have several types of training available for you. And thank you for listening to the webinar. If you have any questions, please let me know. Type it in chat.